All right, so this Codelab video is going to be on the testing basics. So you go to codelabs.developers.google.com, search test, and it is this one right here, 05.1, testing basics. All right, so that's the one I'm gonna do. Here we go. Let me move this over here. All right, so this Codelab is part of the Advanced Android and Kotlin course. You'll get the most value out of this course if you work through the Codelabs in sequence, but it's not mandatory. All the course Codelabs are listed on the Advanced Android and Kotlin Codelabs landing page. Cool. This Codelab is part of a series of guides that guides you through how to test your Android project. We recommend that you do all the Codelabs in order because they progress through tasks step by step. Codelabs are 5.1, 2, and then 3. Okay, so we'll do dependency injection and test doubles next. All right, intro. When you implemented the first feature of your first app, you likely ran the code to verify that it worked as expected. You performed a test, albeit manual test. As you continue to add and update features, you probably also continue to run your code and verify it works. But doing this manually every time is tiring and prone to mistakes and does not scale. Computers are great at scaling and automation, so developers at companies large and small write automated tests, which are tests that are run by software and do not require you to manually operate the app to verify the code works. What you'll learn in this series of Codelabs is how to create a collection of tests, known as a testing suite, for a real-world app. The first Codelab covers the basics of testing on Android. You'll write your first tests and learn how to test LiveData and ViewModels. What you should already know, ViewModel and LiveData, application architecture, following the pattern from this one. I want to see this Codelab real quick. Oh, so it's like all this stuff. Yeah, I know that well enough. Okay, what you'll learn about the following topics: how to write and run unit tests on Android, how to use TDD, how to choose instrumented tests and local tests. You'll learn about the following libraries: JUnit4, Hamcrest, AndroidX test library, architecture components, core test library. What you'll do: set up, run, and interpret both local and instrumented tests in Android, write unit tests in Android using JUnit4 and Hamcrest, write simple LiveData and ViewModel tests. Here we go. Next. In the series of Codelabs, you'll be working with the To-Do Notes app. The app allows you to write down tasks to complete and display them in a list. You can then mark them as completed or not, filter them or delete them. This app is written in Kotlin, has several screens, uses Jetpack components, and follows the architecture from a guide to app architecture. That's a Codelab, I believe. Oh, no. Okay. By learning how to test this app, you'll be able to test apps that use the same libraries and architecture. Cool. Next. Oh, wait. Oh, I went too far. All right, getting started. Download the source code, or you can clone it. I'm going to clone it. So let me I'm just grabbing the URL here. I'm going to do get from VCS, paste that in there, and then do clone. All right. Starter code is on the starter code branch. Good to know. All right, let's see. Familiarizing yourself with the code. In this task, you'll run the app and explore the code base. This to-do app starter code has the same testing setup: folders, library dependencies, and sample tests as a brand new project created with Android Studio. All of the additional tests and test configuration setup will be covered in these Codelabs so that you can apply the same testing practices to your own Android apps. Awesome. All right, step 1, run the sample app. Once you downloaded the To-Do app, open it in Android Studio and run it. It should compile. Explore the app by doing the following. Create a new task. All right, let's open it up. I have multiple JDKs, so I have to change something. You probably don't, so don't worry about what I'm doing right now. I always get an error. Let me use the embedded one, apply. You probably didn't have to do that, so, all right. Okay, what does it say? It says, run the app. So let me go ahead and run it. I'll do it on Pixel 4 API. A new task with the plus, the fab. Enter a title first, then additional information about the task. Save it with the green check fab. Okay, and did it run? Oh, no, it's still going. In the list of tasks, click on the title of the task you just completed. Look at the detail screen for that task to see the rest of the description. In the list or on the detail screen, check the checkbox of that task to set its status to completed. Okay. Go back to the task screen. Open the filter menu. Filter by active and completed. Open the nav drawer. Click stats. Go back to the overview screen. All right, so we got to kind of just go through this app. All right, let's do it. All right, so I'm going to make a new task. It's going to be learn Android, if I can spell, testing. All right, learn how to write unit and instrumentation tests for Android. All right. There's my new task. All right. What does it say? I saved it. Click on the title of the task I just completed. All right, there we go. Looks good. In the list or check the checkbox. Boom, done. All right, go back. Oh, nice strike through. Looks good. Open the filter menu and filter by active and completed. Oh, very nice. I could actually use this. Open the nav drawer and click stats. All right, look at that. Completed 1/3. Go back to the overview screen. And it says something about, what does it say? Clear completed. All right, got rid of the completed. All right, I think I can stop it now. I'm gonna close this. The sample app code. The To-Do app is based off of the architecture blueprints, testing and architecture sample. The app follows architecture from a guide to app architecture. It uses view models with fragments, a repository, and room. If you're familiar with any of the below examples, this app has a similar architecture. I've seen both of these two. I don't know about the other ones. Not Udacity. I've never used that website. I heard it's good though. Let's see. It is more important that you understand the general architecture of the app than have a deep understanding of the logic at any one layer. All right, someone drew a nice little picture. All right, different screens. And this is how they're divvied up. You got task activity, tasks fragment, tasks view model. It has live data. Default tasks repo, tasks local data source room, and then network. Okay, so the repo deals with whether it uses room or network. Navigation component. Okay, the to-do application, layouts in XML. All right, this is actually really good drawing. All right, here's a summary of the packages you'll find. Let's see, add edit text. This adds or edits a task, or add edit task. Okay. UI layer, code for adding or editing a task. Data layer deals with the data layers of the tasks. It contains database, network, and repo code. Statistics, the statistics screen. It's a UI layer code for the statistics screen. Task detail, the task detail screen, UI layer. Okay. Tasks, task screen, UI layer code for the list of all the tasks, and then utility classes, shared classes used in various parts of the app. For example, swipe refresh layout used on multiple screens. Okay. Data layer. This app includes a simulated networking layer in the remote package and a database layer in the local package. Oh, I see. Okay, so simulated network in the remote package, database in the local. All right, for simplicity in this project, the networking layer is simulated with just a hash map with a delay rather than making real network requests. The default tasks repo coordinates or mediates between the networking layer and the database layer and is what returns data to the UI layer. UI layer. Each of the UI layer packages contains a fragment and a view model along with any other classes that are required for the UI, such as an adapter for the task list. The task activity is activity that contains all the fragments. Navigation. Navigation for the app is controlled by the navigation component. It is defined in the navgraph XML. Navigation is triggered in the view models using the event class. The view models also determine what arguments to pass. The fragments observe the events and do the actual navigation between screens. Cool. All right, number 5, running tests. In this task, you'll run your first tests. In Android Studio, open up the project pane and find these 3 folders. Okay. These folders are known as source sets. Source sets are folders. Let me go find them right now. Oh, here we go. Found them. All right. These folders are known as source sets. Source sets are folders containing source code for your app. The source sets, which are colored green, Android test and test, contain your tests. When you create a new Android project, you get the following 3 source sets by default. They are main, contains your app code. This code is shared amongst all different versions of your app you can build. Known as build variants. Android test contains tests known as instrumented tests. I've always heard them called instrumentation tests, not instrumented. I prefer it my way. All right, test contains tests known as local tests. Okay, the difference between local tests and instrumentation tests is in the way they are run. Local tests, test source set. These tests are run locally on your development machine's JVM and do not require an emulator physical device. Because of this, they run fast, but the fidelity is lower, meaning they act less like they would in the real world. In Android Studio, local tests are represented by a green and red triangle icon. Instrumentation tests, Android test source set. These tests run on a real or emulated device, or also known as an instrument. And so they reflect what will happen in the real world, but are also much slower. In Android Studio, instrumentation tests are represented by an Android with a green and red triangle icon. Okay. Step 1, run a local test. Open test folder until you find example unit test Kotlin file. Right click on it and select run. Okay. Let me make a little more space. It says right click on it and do run. All right, let's see it. Look at that, it passed. Awesome. Let's see, 4 is equal to 2 plus 2. Good thing that test passed. All right, notice the green check marks and expand the test results to confirm that one test called addition is correct passed. It's good to know that addition works as expected. All right, let's make sure we got those. Okay, so make sure these two buttons are checked, and then there's the test. Addition is correct. Awesome. Okay, other ways to run tests. I don't know, this is kind of it's kind of pointless, but whatever, we'll go over it. Each is explained below. I'm just gonna skip all that and show you how I do it. If you want to run, you can rerun this whole test by clicking it right here, and it will rerun. Or you can run an individual test. Let's say there were 100 tests in this class. You could just run an individual test by clicking right here, that little play button. Let's look at imports. Or you can run the whole test, all the tests in this class by clicking that. Or, let's see, right now it says example unit test. Let me run this individual one right here. You can rerun whatever you want right here. Oh, and you can do with coverage. That shows you how much of your app base is covered with unit tests, like how much of your code base. It goes over each function to see if there's a test for like every single function. I don't know if they go over that in this Codelab. All right, that's how I do it. Let's see, make the test fail. Okay, below is the test that you just ran. Yep, that looks like it. Notice that the tests are a class in one of the test source sets, contain functions that start with test annotation, usually contain assertion statements. Android uses the testing library JUnit for testing. Both assertions and test annotation come from JUnit. An assertion is the core of your test. It's a code statement that checks that your code or app behaved as expected. In this case, the assertion is assert equals 4 and then 2 plus 2, which checks that 4 is equal to 2 plus 2. To see what a failed test looks like, add an assertion that you can easily see should fail. It'll check that 3 equals 1 plus 1. So let's add, we'll add that. All right, let me run the whole test again. And yep, looks like it failed. Expected 3, actual 2. Click to see the difference. Oh, nice little diff. All right, that works as expected. Awesome. Also notice a single failed assertion fails the entire test. You are told the expected value 3 versus the value that was actually calculated 2. You are directed to the line of the failed assertion. Does it give you a line number? Oh yeah, it does. Line 16. Yep. All right, run an instrumentation test. Open instrumentation test, or let's see, instrumentation tests are in the Android test source set. Open Android test source set. Run the test called example instrumentation test. Okay. All right. And then let's run it. Emulator, because it runs on an instrument. And you can see here, it's asserting, let's see, the package name is equal to app context package name. All right, cool. That worked out. Let's go back to the Codelab. Unlike local tests, this test runs on a device. We saw that. If you have a device attached or an emulator, you should see the test run on the emulator. What makes this an instrumentation test? Well, it runs on an instrument. That's number one. A test is an instrumentation test if it needs or benefits from being run on an emulated or real device. The instrumentation tests almost always use Android OS or Android framework. In this test, you're getting a context using instrumentation registry. This allows you to get the package name and do a comparison. The difference between this test and the last test is that you're using Android framework code. Okay, next. All right, let's write our first test. In this task, you'll write tests for get active and complete stats, which calculates the percentage of active and complete task stats for your app. You can see these numbers on the statistics screen of the app. All right, step one, create a test class. In the main source set, in to do app statistics, open statistics utils Kotlin file. Okay, let's open that. It says in the main statistics utils Kotlin file. Here we go. What's next? Find the get active completed status function. I saw that. The get active and completed stats function accepts a list of tasks and returns a stats result. Stats result is a data class that contains two numbers, the percentage of tasks that are completed and the percentage that are active. Android Studio gives you tools to generate stubs to help you implement tests for this function. Right-click Get Active and Completed Stats and select Generate Test. Okay. Okay, so this is just a file, and that's a internal function, and then there's the data class. I see, it's a float. Okay. All right, let's see. Generate. Where's generate? Right here. Let me do it again. Generate. Test. We're going to select JUnit4 and get rid of KT and click OK. And it's going to go in this one, app source test, not app source Android test. Those are instrumentation tests. Goes in this one. All right. Yep. Let's add that to Git. All right, create the test, opens that dialog, went through all that, change the class name. I did that. All right, keep the rest of the defaults. JUnit4 is the appropriate testing library. I selected JUnit4. Destination package is correct. It mirrors the location of statistics utils class, and you don't need to check any of the check boxes. This just generates extra code, but you'll write your test from scratch. Press OK. The choose destination directory, yep, I selected that one. Local test because, okay, opens. You'll be making a local test because your function is doing math calculations and won't include any Android specific code. So, there's no need to run it on a real device or emulated device. Select test directory. Okay, I did all that. Notice the generated statistics util test class in test/statistics. Let's see it. Did I make it? Yep, there it is right there. Cool. Okay. Write your first test function. You're going to write a test that checks if there are no completed tasks and one active task, that percentage of active tests is 100%, and the percentage of completed tasks is 0%. Open statistics utils test, create a function named get active and completed stats underscore no completed underscore returns 100 0. Okay. I'm just gonna copy that function right here. Oop. Copy this whole function, and I'm gonna put it right there. All right, what's next? Add the test annotation. Okay. We'll select JUnit. All right, good, good. All right, create a list of tasks. Okay. All right. Where do these go? I think these go above it. Oh, did I put that? I should be... No, it should be below it. Right there. And then import that. Good. Okay. Call get active and completed stats with these tasks. Okay, copy this. Go to Android Studio. All right, there's the result. Cool. All right, check that result is what you expected. All right. Okay, check the result. All right. Here is the completed code. Let's go over that and run this. So first it gets the tasks. It's a list of tasks. I'm gonna look at this. Okay, so this is just a job, an object. All right. Entry ID, UUID, random, completed, description. Okay. Okay, and that goes into a database. That's the table name. Okay. So it's a list with just one, I believe. Okay, result, call your function get active and completed stats. So it takes that list, total tasks, gets the size, number of active tasks, tasks.count. Oh, so it iterates over them and counts. Yep, it counts how many is active is true, and then returns stats result. So yeah, it divides number of active tasks and task size, and then multiplies them by 100 to get the percentage. Okay, that's pretty straightforward. Let's run this. All right, did it run? Yep, looks like it ran. It passed. Awesome. All right, run the test. Yep, it should pass. It did. All right, now we get to add the Hamcrest dependency. Because your tests act as documentation of what your code does, it's nice when they are human readable. Compare the following two assertions. All right. Okay, assert equals result completed tasks %0, and then assert that task, let's see, result completed tasks % is 0. Honestly, I kind of like the equals better, but whatever, we'll use it. Second assertion reads much more like a human sentence. Yeah, it does. It's more like a human sentence. It is written using an assertion framework called Hamcrest. Another good tool for writing readable assertions is the truth library. You'll be using Hamcrest in this Codelab to write assertions. Open the Gradle file. and add the following dependency. Okay. All right, let's go to our Gradle. I don't think we have this Hamcrest version. I'm gonna look at the other, no. Okay. So I'm gonna put 1.0.0 just because they have to at least have that, and I see they do. They have a newer version. So there we go. Hamcrest 1.3. Try again. No, all the dependency versions are defined in the project's build.gradle file in the Ext block. These library versions have been tested together for this Codelab. Usually you use implementation when adding a dependency, yet here you're using test implementation. When you're ready to share your app with the world, it is best not to bloat the size of your APK with any of the test code or dependencies in your app. You can designate whether a library should be included in the main or test code by using Gradle configurations. The most common configurations are implementation, test implementation, and Android test implementation. The first one, dependency, is available in all your source sets. Second, it's just available to the local unit tests, and then the third one is just available to your instrumentation tests. All right, which configuration you use defines where the dependency can be used. If you write, that's what I did just write, isn't it? Hamcrest all, yep, org Hamcrest all. This means Hamcrest will only be available in the test source set. It also ensures that Hamcrest will not be included in your final app. Okay, that's good. Step 4, use Hamcrest to write assertions. Update the get active and completed stats, that test function, to use Hamcrest assert that instead of assert equals. Okay, so we want to use this instead. We got to import these, and they're matcher, I believe. Oh, and it says it's deprecated. I think, let's get rid of this assert. There we go. We have to use the Hamcrest one, not the JUnit for our assertion. There we go, now it works. Okay. Note you can use the import. Yep, I did that. If prompted, the final test will look like the code below. Okay. Yep, it does. Why are there back quotes in the is? Because is a key word, so it has to be able to distinguish that it's using the is part of Hamcrest and not the keyword in Kotlin. You see, that's a keyword, so that's why we use those ticks, back ticks. All right, run your updated test to confirm it still works. Let's do it. Run it. I need to update Android Studio as well. Awesome, it works. This Codelab will not teach you all the ins and outs of Hamcrest, so if you'd like to learn more, check out their official tutorial. Okay, there are a few other strategies you can use for writing readable tests, both of which are demonstrated in the test you just wrote. Given when then, One way to think about the structure of a test is to follow given, when, then, testing mnemonic. This divides your test into 3 parts. Given, the setup, when is the action that you perform, that you're testing, then is the assertion. Okay. Subject under test. Okay, here's the naming convention for the tests. Subject under test is the method or class that is being tested. Get active and completed stats. Okay. Next is the action or input. Action or input, no completed. And then finally, you have the expected result. Returns 100, 0. Okay. All right. Task, let's see, the number 7. Oops, I just clicked that. I don't know why. It's not an actual link. Okay. This is an optional task for practice. All right, let's do some practice. In this task, you'll write more tests using JUnit and Hamcrest. You'll also write tests using a strategy derived from the program practice of test-driven development. Programming thought that says instead of writing your feature code first, you write your tests first. When you write your feature code with the goal of passing then you write your feature code with the goal of passing your tests. All right, step 1, write the tests. Write tests for when you have a normal task list. Okay? If there is one completed task and no active tasks, the active tasks percentage should be 0 and the completed tasks should be 100. If there are 2 completed tasks and 3 active tasks, the completed percentage should be 40 and the active percentage should be 60. Okay, so I think we're supposed to write these tests. All right. Okay, so what was the name of it? Okay. If there's one completed task, no active, the active task. Okay, so it's pretty similar to this. I'm going to copy this. Okay, except what was the first one? One completed task and no active tasks. Dang it. So one completed, no active, something like that, right? I'm following along this one. All right, so if there's one completed, no active, the active tasks percentage should be 0F and completed should be 100F. Okay. So these are flipped. Returns 0, 100. All right. Okay, so let's grab these again. I'm just gonna paste them in here. Okay, so get active and completed stats. One completed, no active. So completed should be true, and there's no active. So let's see, active should be 0, and then completed should be 100, right? Let's test it out. I think that's right. Yep, look at that. Let's run the whole thing. Let's see how it looks. Active and completed. One completed, no active. Okay. Cool. All right, and what's the second one? If there are 2 completed tasks and 3 active tasks, okay. So 2 completed, 3 active. I'm just gonna copy this whole thing. What was it again? It was 2 completed, 3 active, right? I'm looking at this one. 2 completed, 3 active. Okay. 2 completed, 3 active, and it should return, let's see, 2 completed, 3 active, and it should be 60/40. Okay, so 2 completed, so the completed should be 40. And, right? 3 active, yeah, that should be 60. Okay. And now we have to make these tasks. So these are our completed ones, 2 completed. And then here we need 3 active ones. All right, so we have 3 active and then 2 completed. So then that's what our test says. 2 completed, 3 active. Let's run it. There we go. Nice, cool. Okay, step 2, write a test for a bug. The code for get active and completed stats as written has a bug. Notice how it does not properly handle what happens if the list is empty or null. In both of these cases, both percentages should be 0. All right. Yep, I could see that. Yeah, see. All right. To fix the code and write tests, you'll use TDD. Follow these steps. Write the test, use given when then structure, and with a name that follows the convention. Confirm the test fails. Write the minimal code to get the test to pass. Repeat for all tests. Okay, let's look at that picture. Yep. Test fails, implement, test passes. Okay. Instead of starting by fixing the bug, you'll start by writing the tests first. Then you can confirm that you have tests protecting you from ever accidentally reintroducing these bugs in the future. If there is an empty list, then both percentages should be 0. If there was an error loading the tasks, the list will be null and both percentages should be 0. Run your tests and confirm they fail. Oh, so these are the ones we're supposed to write. Oh, they did it a little different. I said both. Okay, so these are the 2 we got to do. Get active and completed, empty, and error. Okay. So I'll do empty first. Oops. And it should return 0, 0. Okay, and this is for an empty list. Okay, and then create your function. Okay, and assert that. There we go. This should fail, and I'm gonna make the other one real quick before, oops. Okay. It should be error. Did I do that right? Return 0, 0. Return zeros. Okay, close enough. Okay, so the list will be null. That's when the list is null. Okay. All right, so those two should fail. Oh, it didn't work. What does that expect? It expects... Okay. Now let me run it. Okay, here we go. Null pointer right there. And that makes sense because we're passing a null list. And what's this one? Expected 0 got not a number. Okay. Confirming your test fails is helpful. If your test passes, then you haven't written code to make it pass. Or when you haven't written code to make it pass, then you know something strange is going on. Perhaps the test always passes, which is a useless test, or the test is not using the right code. Fix the bug. Now that you have your test fix the bug. Fix the bug in get active and completed stats by returning 0 if tasks is null. Okay. Okay, so I'm just gonna copy this whole thing. Oops. There we go. Now let's run it, that same test. What? It's still failing? Oh, expected 0 but was 0f. Oh, I forgot to put the float with these. Yeah. Yeah, it's supposed to be a float. Okay, let me run these all again. There we go. All passed. Nice. Oh, good. By following TDD and writing tests first, you've helped ensure that new functionality always has associated tests. Thus, your tests act as documentation of what your code does. Your tests check for the correct results and protect against bugs you've already seen. So to learn more about TDD in Android, you can watch TDD. Oh, it's from Google I/O 17. It's been replaced with the AndroidX test. Okay. Writing more tests. Here are all the tests and corresponding feature code. Yep, I wrote all those. All right, here we go. All right. Let's see, setting up a ViewModel test with AndroidX test. In the rest of the Codelab, you'll learn how to write tests for two Android classes that are common across most apps, ViewModel and LiveData. You start by writing tests for the tasks ViewModel. You're going to focus on tests that have all their logic in the ViewModel and do not rely on repo code. Repository code involves asynchronous code, databases, and network calls, which all add test complexity. You're going to avoid that for now and focus on writing tests for ViewModel functionality that doesn't directly test anything in the repository. Okay. The test you'll write will check that when you call add new task method, the event for opening the new task window is fired. Here's the app code you'll be testing. Okay. What is event? In the To-Do app, you are using a custom event class to make LiveData represent one-time events like navigation or snack bar popping. The event LiveData is observed in the tasks fragment. In this case, new task event represents that the plus fab was pressed, and you should go to Add Edit Task Fragment. You can learn more about events here and here. I'll keep going. Make a task ViewModel test class. Follow the same steps as you did before. Okay, open that class, tasks ViewModel. Let's go to that. I'm gonna close some of these. Okay, we go to generate, test. Let's see what they say. Why make the ViewModel a local test? Pure ViewModel tests usually go in test source set because the ViewModel code shouldn't rely on the Android framework or OS as a local test. It will also run faster because you run the test on your local machine, not an emulated device. Okay, true. Start writing your ViewModel test. Oh, okay, we gotta go through all those. It's probably just the defaults. JUnit4. All right, we'll leave everything blank. And then we'll do test, it said. Add. All right. Okay, let's see. Create a new test called add new task. Oh, it's right here. Add. It's okay. It's adding too many. What is this? That was the wrong thing copied. Okay. All right. What about application context? When you create an instance of tasks ViewModel to test, its constructor requires an application context. But in this test, you aren't creating a full application with activities and UI fragments. So how do you get an application context? Android test libraries include classes and methods that provide you with versions of components like applications and activities that are meant for tests. When you have a local test where you need simulated Android framework classes, honestly, I kind of think this is wrong. You really shouldn't do this. Like, you should make your tests so you don't. I know some view models do take application, but I feel like you could mock it. Well, actually, no, never mind. I take that back. You would need it for application. Some view models take an application as I think they're called application view models. What is tasks? Oh, Android view model. Yeah, it takes an application. All right, so this one, yeah, that makes sense. But generally speaking, you don't want to do that. It's a bad idea. It's easier just to pass what you need and kind of keep that separate. Roboelectric. Let's see, Android test. Annotate the class with JUnit4 test runner and write test code. Okay. Oh, here we go. I don't want to type that out. Oh, we were supposed to add that before doing that. So let me go ahead and add this. I don't think it'll matter. This is, oops, no. Okay, JUnit extension, that was the one that was, I just added. Okay, it's the same thing, so I can get rid of that. Okay, and then do a sync. There's probably an error. Which one? This one, Roboelectric. I don't really like Roboelectric. All right, 4.5, try it again. All right, there we go, it works. All right, synced. All right, add that runner. Did that. Okay, use AndroidX test. At this point, you can use the Android test library. This includes the method get application context, which gets an application context. Create a task to view models using that. Okay. Okay. Import that. Call add new task on that view model. Let's do that. Okay, at this point, your test should look like the code below. It does. Run your test to confirm it works. All right. All right, it works. How does AndroidX test work? What is the AndroidX test? AndroidX test is a collection of libraries for testing. It includes classes and methods that give you versions of components like applications and activities that are meant for tests. As an example, this code you wrote is an example of an AndroidX test function for getting an application context. One of the benefits of AndroidX test APIs is that they're built to work for both local and instrumentation tests. This is nice because you can run the same test as a local test or an instrumentation test. You don't need to learn different testing APIs for local or instrumentation. For example, because you wrote your code using AndroidX test libraries, you can move your tasks view model test class from the test folder to the Android test folder, and the test will still run. Interesting. All right. The get application context works slightly differently depending on whether it's being run as a local or instrumentation test. If it's an instrumentation test, it will get the actual application context provided when it boots up an emulator or connects to a real device. If it's a local test, it'll use a simulated Android environment. Okay, what is Roboelectric? The simulated Android environment that AndroidX tests uses for local tests is provided by Roboelectric. Roboelectric is a library that creates a simulated Android environment. It's basically just mocking on steroids. They just mock everything, and it's quite expansive or extensive. Let's see. For tests, it runs faster than booting up an emulator and running on a device. Without the Roboelectric dependency, you'll get this error. All right, what does runs with this do? A test runner is a JUnit component that runs tests. Without a test runner, your test would not run. There's a default test provided by JUnit that you get automatically. Runs with swaps out the default test runner. JUnit4 test runner allows for AndroidX tests to run your tests differently depending on whether they are instrumentation or local. Okay. Yeah, so it's like a layer of abstraction that determines what to do when it's a local or a instrument test. Okay. All right, fix roboelectric warnings. When you run the code, you'll notice that, did I get that warning? I don't see that warning. Let me run it again. Let's see. Okay, here we go. No manifest file found for that. Falling back to Android OS. Okay. You can fix the no manifest file by updating your Gradle file. Add the following line to your Gradle file so that the correct Android manifest is used. Okay, this is in the app Gradle file. The app Gradle file, you'll see app right here. I believe it goes right there. All right, let's resync that. The warning. All right, I had to look ahead in the code to see what was wrong. And the reason was I kept on getting an error. So first things first, go through, make sure you have these dependencies just like I do. Roboelectric, Android test version, and then the version. They're just the default from the Codelab. They're not changed. Nothing's changed actually in this file at all. But here, yeah, you have to add that to get rid of that manifest error. And then here, added these, the Roboelectric 4.5.1. And then I'm going to comment this out and then run it. And you get this error. Package, target version. Okay, and the way you fix that is by adding this right here, this config, to use specified SDK30. So now when I run it, now it works and it passes. Awesome. All right, so they didn't specify. I didn't see this in the Codelab, but you need to add that. Let me check in here, make sure it's not here. No, it's not here. All right, yeah, so you can pretty much ignore this. Okay, let's go to the next one. All right, task, writing assertions for live data. In this task, you learn how to correctly assert live data value. Here's where you left off with add new task, sets new task event, view model test. Yep, that's where we left off. To test live data, it's recommended you do two things. Use instant task executor rule and ensure live data observation. All right, step one, use instant task executor rule. Instant task executor rule is a JUnit rule. When you use it with the @get rule annotation, it causes some code in the instant task executor rule class to be run before and after tests. To see the exact code, you can use keyboard shortcut Command B to view the file. This rule runs all architecture components related background jobs in the same thread so that the test results happen synchronously and in a repeatable order. When you write tests that include testing live data, use this rule. All right, so this is important. Add the Gradle dependency for architecture components core testing library, which contains this rule. All right, let's add this. Let's sync it. I'm going to delete that and just do 1.0.0, and then it'll give me this warning. It says there's a newer version, 2.1.0. Then I sync it. Okay, got that in. Open tasks view model test. Add the instant task executor rule inside the task view model class. Okay, so we got to add this guy right here. And let's import this stuff. Awesome. Now we got that. Step 2, add the LiveData test util class. Your next step is to make sure LiveData you're testing is observed. When you use LiveData, you commonly have an activity or fragment. Lifecycle owner observe the LiveData. Yep, that looks familiar. This observation is important. You need active observers on LiveData to trigger any on-changed events, trigger any transformations. To get the expected LiveData behavior for your view models LiveData, you need to observe the LiveData with a lifecycle owner. This poses a problem. In your task's view model test, you don't have an activity or fragment to observe your LiveData. To get around this, you can use observe forever method, which ensures the LiveData is constantly observed without needing a lifecycle owner. When you observe forever, you need to remember to remove your observer or risk an observer leak. This looks something like the code below. Examine it. Okay, so I'm going to copy this. This goes in that test below where we instantiate the view model. Okay, we can get rid of this old one. Okay, let's import some things. Import observer, which one? I think it's this, the life cycle. Yep. AndroidX life cycle. Event, import that. Which event is it? I think it's this event. Ours from the app. Okay, assert that. We want to import that from Hamcrest. And then not, where's that come from? Let's do Hamcrest as well. We'll do it from this one, hamcrest.matchers, and then null value. Same thing, hamcrest matchers. Okay. That's a lot of boilerplate code to observe a single live data in a test. There are a few ways to get rid of this boilerplate. You're going to create an extension function called LiveData test util to make adding observers simpler. To make a new, make a new file called LiveData test util in your test source set. Okay, I'm going to copy that, make a new file make it in here. And it's a file. Yes, add that. And then go back. And I'm just going to copy all this. All right. So this is, it's an extension function to do all of that business. It's a function. Okay. It's on live data. Time unit seconds. Okay, 2 after observe. Okay, data of type T starts with null, latch, countdown, latch, count 1, observer. That's an object. Or it's an interface implementation of that. Right? Let me double check that. Yep, interface. Data equals O. Where is O? Okay, that's past. Oh, right there. Latch countdown, get or wait value, remove observer. Okay, this observe forever. Alright, so that's just a bunch of boilerplate. Okay. This is a fairly complicated method, very true. It creates a Kotlin extension function called get or await value, which adds an observer, gets the live data value, then cleans up the observer. Basically a short, reusable version of the observe forever code. For a full explanation of this class, check out this blog post. I'll take your word for it. As you write your own test that tests live data, you can similarly copy and use this class in your code. I surely will. Use get or await value to write the assertion. In this step, you use the get or await value method and write an assert statement that checks that the new task event was triggered. Get the live data value for a new event task, near a new task event using get or await. Am I already doing that? Let's see. I think, where does it go? Assert that it's, I don't know if I put it in the right place. Oh. Oops. That's already in there. Let me, okay, what is the get content if not handled? In the to-do app, you are using a custom event class to make live data represent one-time events like navigation or snack bar popping up. Get content if not handled provides the one-time capability called the first time it gets the content of the event. Any additional calls to get content if not handled for the same content will return null. This is how event data is accessed in the app code, and thus we're using it for tests. You can learn more about events here. All right, the completed test should look like the code below. Oh, that's much simpler. Let me just copy that. Okay. All right, so let's look at this test. It gets the view model, adds a new task, and then gets that value, new task event, and there's the extension function to observe it, and assert that value, get content if not handled. Oh, I see. That's from event. Okay. Let's run it, make sure it works. Run your code and watch the test pass. All right, I'm gonna go forward and let's see if it actually passes. And it does, awesome. All right, writing multiple ViewModel tests. All right, now that you've seen how to write a test, write one on your own. In this step, using the skills you learned, practice writing another task's ViewModel test. Write your own ViewModel test. Okay, you'll write set filter all tasks, task add view visible. This test should check that if you've set your filter type to show all tasks and the add task button is visible. Okay. It says using that previous test for reference, write a test in task view model test called that sets the filtering mode to all tasks and asserts that the task add view visible live data is true. Okay, so here's our function. Oops. Okay. Okay, the task filter type enum for all tasks is that. The visibility of the button is controlled by that live data. Okay, run your test. Compare your test to the solution. I'm just going to go with the solution because this is taking a while. Okay. Now let's look at it. Let's bring in the Hamcrest matchers. All right, we get the view model, set filtering to all tasks, and then assert that tasks view model get or await value. Okay, so you call that on live data. Cool, and that's true. Let's run this test. Check whether you do the following. You create your task view model using the same AndroidX application provider get application context statement. You call set filtering method, pass in all tasks, enum, and then you check that task add view visible is true using the get or await value. Step 3, add a app before rule. Notice how at the start of both your tests you define a view model. Okay, so yeah, I was thinking that too. So this would be a lot easier. Okay, it looks like that test passed. And we're going to do an app before. This executes before every test. It's going to do that so we can get rid of the view model when we instantiate the view model. Makes our code a lot nicer and smaller. Let's make sure that all the tests pass. And you notice how when we're using application provider, it takes a lot longer. Things take a lot longer than the previous test. All right, cool. Your final code should look like that. Yep, that's what it looks like. All right, in the next lessons, you'll learn a lot more about testing view models. Right now, you can't test any methods in the view model that use view model scope. You'll see an error that says exception in main thread, blah, blah, blah. Similarly, testing methods that use default task repository is tricky because this calls code in the networking code and database code. You'll learn all of this in the following Codelabs. Cool. All right, there's the solution. Cool. All right, that's it. So my takeaway, I don't like having context in view models. I think it's an anti-pattern. I would rather get, that was especially true before view models were like official with Android and part of the architecture components. However, now that there's some view models that take application in their constructor, like the view model in this Codelab, that's kind of changed. I think that's changed. So, like right here, the Android view model. So, I don't know, things have kind of changed there. I'm still a bit weary about that. I wonder if you could just mock it. I don't know what does it do here? Let's see, sets the application, extends view model. So I feel like you could just mock it, but I'm not sure what, maybe not. Maybe it's really painful to mock it and it's not worth it. But I would look into that before I use RoboElectric. I'm not really a big fan of RoboElectric. Yeah, I think it's just kind of an anti-pattern putting context into view models, but I could be wrong. I haven't really looked at this stuff since prior to architecture components. So take it with a grain of salt, do your own research. All in all, this is a good Codelab though. It was a little confusing. They were missing this config. That was important. But yeah, I hope you enjoyed the video. Thanks for watching.